Our last speaker before we go to panel session, and I encourage everyone to be thinking of Q&A, is Dr. Alex Szopinska. Alex is the Senior Innovation and NPD Manager at Livalta, which is IBioIC's new business for responsible proteins. I like the term responsible. Alex's background is in protein biochemistry, in microbiology, and in food and feed processing technologies, and she's going to discuss new protein sources for the animal feed industry. And I'll pass to you, Alex.
Thank you very much, Jim. Today I would like to tell you a little bit about our journey towards new proteins for animal feed, but also food. Can I have next slide, please? But first, before I start, I would like to introduce IBioIC. IBioIC is a part of bigger and very much diversified group, Associated British Foods, which is active in a number of industrial segments like sugar production, retail, grocery, ingredients, and we are an agricultural division of this business. IBioIC operates in 65 countries, and with its products and services, it's reaching up to 5 million farmers globally. IBioIC has a number of specialized businesses, and I'm a member of a new business called Livalta. Can I have next slide, please? Livalta was formed to develop and commercialize new proteins. We focus very much on the bringing functionality and nutrition in the new products. We aim to contribute to making our food systems more responsible, first by doing more from less. So, for example, adding more value to existing co-products and byproducts. And the second point is focusing on local sourcing of raw materials to reduce this heavy, complicated supply chains. So we build technology and science platforms to keep on innovating our products. And what is important to mention here, we are a startup, even with support from such a big organization. We are a small interdisciplinary group of very motivated people. So I will show you what we are planning to do. Please, next slide. Global requirements for proteins are growing and will be growing. I think Polly already described this topic very well, so I will basically repeat. The global data shows that the market of protein-rich ingredients will reach 400 million tons by 2020. And as you see on the second graph, we still will be largely dependent on soy supply. So as my colleagues mentioned, on one hand, we will need more proteins, but on the other hand, we need to focus on reduction of land use, reduction of environmental footprint. So we call it protein challenge. And now I would like to show you how we would like to tackle this big challenge. Please, next slide. So as Livalta, we keep exploring number of solutions for new proteins. Among them, developing products from co-product yeast, we call them spent yeast from different industries, but also adding value to plant-based co-products from a number of industries. We also work hard on technological improvement of locally grown pulses and legumes. And of course, we look into new, so insects, single cell proteins, algae. We continue this work with external parties, with also a large network of research institutions. Can I have next slide, please? I would like to show you a very interesting example of our recent development. It's a new product developed based on spent bioethanol yeast. The product, we called it Livalta Cell. And can I have next slide, please? Overall, the health benefits of yeast and yeast products has been known for ages. And there are also hundreds of publications showing benefits of using yeast products in the animal feed industry. Well processed yeast products may provide both nutrition and functionality because it's a good protein source, but also yeast cell, for example, yeast cells components may provide functionality, for example, promotion of healthy gut development, immune stimulation, but also it helps in reduction of pathogens pressure. So can I have next slide? Thank you. I would like to show you a small snap from our R&D work. So what were the key steps to develop these products? So first of all, we screened locally available raw materials. We were looking for yeast source, which would be pure yeast, but also yeast strains which are able to synthesize high level of bioactive components. Of course, non-GM, free of antibiotics and heavy metals. So this is all well secured by QC systems in place. The second very important step was process development. For this particular development, we focused on the enzymatic approach. So we did a really big screen of enzymes, which could allow us to first improve the nutritional value of this co-product, but also to enhance functionality. And this work was supported by extensive in vitro and ex vivo testing. And when we get to the right prototypes, then of course the most important part, we validated product performance in animal in vivo. Can I have next slide, please? This is just to visualize how spent yeast product was modified, was treated with enzymes, and we managed to release all the internal content, so containing proteins, vitamins, minerals. And you can see that this is nicely reflected in the increased digestibility of this product. This is results from in vitro work, pepsin digestibility. Okay, next slide. And the second objective of this processing of spent yeast was enhancing its functional properties. One of the key properties of yeast cell walls, which are important for our industry, is their ability to prevent bacteria from adhesion to the animal gut, pathogenic bacteria, of course. There is a theory based on current model, based on literature, assumes that yeast mannan can competitively bind to the fimbria of bacteria, like for example E. coli or pathogenic salmonella, and can block receptors which then cannot attach to the intestinal receptors. So basically, we can prevent bacteria from invasion. And you can see in this graph, this is ex vivo model of bacteria adhesion, piglet model, how enzymatic treatment of spent yeast could enhance this property of the product. So you can see that this is actually salmonella binding inhibition. So you can see that there is a massive difference. So you can see that proper processing of the spent materials can improve both nutritional and functional value. Can I have a next slide, please? That was the first example, but of course we don't stop. We keep on innovating, and we would like to really continue work to identify perfect match between raw materials and technologies to develop, we call it future protein 2.0. Key requirements for this protein is, of course, local sourcing, sustainability, economics, and consistent supply, quality, and functionality. Can I have just very last slide? So yes, so basically at the last slide there are my contact details. I'm very happy to discuss with members of this great community if you have more questions, and also if you would like to share your results and discuss how we can join our forces to reach these goals, please contact me. Thank you very much.